Imagine that you're looking out on space, except that there aren't any stars, planets, or galaxies, just space. If you zoomed up very close to this space, you'd find it full of atoms and dust. Direct your attention to this atom. It's a hydrogen atom. Most of the atoms back then were hydrogen atoms. They made up almost all the matter. Stars are made up of atoms and are held together by gravity. The closer two atoms are together, the more gravity pulls them towards each other. Everything has gravity no matter how big or small it is. The bigger a clump of atoms are, the more gravity pulls other atoms towards them. The denser a clump of atoms are, the faster the atoms move and bounce off of each other. The faster the atoms move, the hotter it gets. Over the time span of millions and millions of years, gravity will cause tons of atoms to clump together in hot, fast-moving, dense clumps. If you zoom in on these clumps and pause it, you'll be able to see what these atoms are actually doing. But before you know that, you need to know that these atoms are almost all hydrogen atoms. That means that they both have one proton, which is positively charged, and one electron. Now back to the fun stuff. Gravity will automatically make these two atoms fly at each other, but they'll bounce off because they're both positively charged. However, when there's more gravity and more pressure and heat, they'll bounce even faster and something incredible will happen. Something called fusion. When the two nuclei are separate, they're both made up of one proton. However, when gravity pushes them together, one of the protons degrades into a neutron, while the other one stays a proton. A one-proton nuclei plus another one-proton nuclei will make a one-proton, one-neutron nuclei, as well as energy. The fusion creates energy because the neutron-proton nuclei has a tiny bit less mass than the protons by themselves. That tiny bit of mass causes an enormous amount of energy. Once fusion starts occurring and energy is made, the mass is considered a star. It starts off with hydrogen, and then those fuse into deuterium, an isotope of hydrogen. The deuterium then fuses into helium. Here's a familiar sight, our sun. Every day, fusion occurs inside our sun, releasing off energy. That energy will counteract the gravity pulling towards the center. If the pressure of the gravity is equal to the push of the energy, then that will be a stable star, which is lucky for us. However, if the force of gravity is larger than the energy coming out, it will collapse in on itself and become a black hole. If the push from the energy becomes greater than the pressure of gravity, the star will go supernova.